In this lecture video, we will understand what is on-site processing. So, on-site processing, it is also called as the edge processing. Now, in on-site processing, it means the data is processed at the same place where it is generated. So the sensor collects the data and a nearby device such as sensor node or microcontroller, it will analyze it immediately, and this reduces the delay and allows the system to take quick actions in real time. So now why this on-site processing, it is important. So here what happens is some applications cannot tolerate delay, that is the latency. Now if the data processing takes too long, it can cause serious damage or the danger. So for example, in healthcare systems, aircraft control systems and the industrial safety systems, the decisions must be made instantly and it must have a quick response. Therefore, in these cases, sending the data to the cloud first would take time. So local processing is necessary. Now, how this on-site processing works. So here what happens is first an event occurs, okay. That is, the event will occur in the environment. Suppose we have a real-time or real-world event which happens, such as the fire or high temperature or the abnormal heart rate. Then the sensor will detect the event and sends the data to the sensor node. For example, we'll take a temperature sensor which detects a change in the temperature and sends the data to the sensor node or the edge device here, okay. Temperature sensor we are using, it detects the change and it will send the information to the sensor node or the edge device. Then local processing happens, okay. So local processing happens, it means that the sensor node immediately processes the data and checks if it crosses a predefined limit, okay. If it predefined limit, and next step is the alert action, where the alert action is generated. If a problem is detected, the system instantly generates an alert or takes action such as activating an alarm here, okay. Activating alarm or activating the sprinkler and sending the notification. These all are the alert actions. Now last is the optional cloud communication, where the system may also send the data to a remote server or cloud for further analysis or storage, that is the data storage or the reports and the insights. Now we have some real-time examples for this. First is the fire detection system, where we will imagine a smart fire detection system in a building, and here the temperature sensor detects a sudden increase in the temperature and the sensor node processes the data locally. If the temperature crosses the safety limit, the system immediately activates an alarm and sprinkler system. So at the same time, the data may also be sent to the cloud server to store the event and notify the emergency services. Then second example is the healthcare monitoring, where in hospitals, patient monitoring systems constantly measure the heart rate and oxygen levels, and the sensor collects the patient's data. The local device processes it instantly, and if the heart rate becomes abnormal, the system immediately alerts the doctors or the nurses. So if the system waited for cloud processing, the delay could risk the patient's life. Then the third example is the flight control system, where the aircraft use many sensors to monitor the speed, altitude and engine performance, and the sensors continuously generate a large amount of data, and the onboard computer processes the data instantly. So if any abnormal condition is detected, the system quickly adjusts the flight controls. So this must happen in milliseconds, otherwise it could lead to dangerous situations. So here some advantages are, it is very fast, that is it has low latency. It means that it is having the quick response in the real time. It works even without the internet, and it is reliable in the remote areas. Also it saves the bandwidth, that is only important data will be sent to the cloud. And it is more reliable because the system continues to work even if the internet fails. Some limitations are, it is having the limited processing power, where the edge devices have less computation and the memory, and it cannot handle very complex analytics. That is the advanced analysis. For advanced analysis, it needs powerful cloud servers. So, on-site processing means processing the data directly at the source using the local devices, and it is mainly used in real-time applications where quick decisions are required. And the system can also send the processed data to the cloud for storage or deeper analysis, but the main decision happens locally. So, this is about the on-site processing or the edge processing.